Thanks for the Camaxon crew for inviting me to say a few words. So we are a local consulting company. We're all about the tools. We do informatics research consulting. Basically, that's all we do. We're really interested in getting the right tools to get the right science done, whether we have to design them and develop them from scratch, purchase them and integrate them, some combination of both. For smaller companies, we'll help set up IT infrastructure and anything else it takes to get things going. And for bigger companies, we can provide some strategic advice or just dig in and do whatever work needs to be done. We've been around since 2005. It's a team of 8 of us. Most of us have scientific backgrounds with lab experience and do programming as well. Let me talk a little bit about how we approach projects. The first thing is to figure out what you want. If I stand here, I'm not blinded. Probably can't see me either. If the first thing we do is try to figure out, what is the current roadblock? Why did you call us up? What's the major pain point? And then we try to find tasks, projects, tools that would really enable some kind of new science. Incremental improvements are okay, but usually you're stuck with something, and we're trying to help identify what that is and get it fixed. We try to understand the project timeline and especially how that compares to how fast requirements are changing, because there's no point in doing a 6-month project if the requirements are going to change out from under us in 3 months. And if we're replacing a system, we really get interested in what went wrong with the first system, because sometimes the technology is fine and it's something about support or something else that got broken. So it's a good idea to understand that before you go in and do another really beautiful technical solution and have it fail again. When we're looking at tools and components, we're trying to understand what's unique about the science of our customers, and also what's similar, and then what's the landscape of things you already have deployed, and how can we fit that together. We're really interested in finding the root causes of things that are broken, if there are things broken. Sometimes we get to work with brand new companies who don't have anything broken yet, so that's always exciting. So we're a consulting company, and I can't show you much of anything that I've worked on. That being said, I will show you some sort of flow charts and some examples for 3 different projects we did out of a pretty large number. And what's exciting for me about this is that I think there are customers in the room for every example I'm going to show you. So I'll keep it pretty high level. So one of the projects I want to talk about is we worked with a company that did very high throughput screening. And what was exciting about they did such high throughput screening, they could do massive dose response follow-ups, lots of off-target studies, and really pull a lot of data together. Otherwise, they had PK and tox and animals and all the other kind of stuff that a biotech would have. They had a mission critical software piece in place. It was a complete UHTS system that was written from scratch, and one of the guys who helped write it is here today, actually. The root problem that we got called in to solve was actually kind of fundamental, which was the data were all there and well organized and well curated and well analyzed, but getting them presented to the chemists in a way that you could sort the potency with the greater thans and less thans and equals was broken. And the detailed analysis of that ended up leading us to change a bunch of things. I say the integration tasks, we ended up, I'll put the cartoon up, doing Syrah as well as some other tools, custom curve fit. So their workflow before had a pre-processing state system that pulls in raw data files, nice normalization and curation workflow built on Spotfire, some transform and load tools, a custom curve fit engine that was sort of on shaky ground, which was one of the issues we worked on, and then an in-house built SAR tool. And then a structure database. And what we ended up changing to was a custom curve fit engine and Syrah. And you also notice that we went to the JChem cartridge, although my team didn't do that. One of the guys who's here today did that work. But taken as a package, we were able to get everything humming along nicely, and the chemists were able to see their SAR, and everything moved smoothly. Another example I'll just walk through quickly. We work with a number of protein therapeutics companies and have built custom databases for various kinds of modified proteins or antibodies or modified antibodies, depending on the company we're working with. And several of these companies also have small molecule efforts, either because they're doing customizations to the proteins or they're doing conjugations. So in this example, this company had a LIMS in place that we wrote called LabSync, but the small molecules were all just tracked by name, not batch or structure, and not associated with the actual data. So we built on Camaxon a pretty simple registration tool. The idea was to do something simple, get it out the door quickly, and get it working. So it looks like any other registration system, I suppose. You draw the structure, you put in information. We were able to integrate it with the existing inventory components inside of LabSync, so they're able to keep track of where the samples are and everything else just by filling in a batch registration form. There's a drag and drop component I'm not showing here that sets the inventory up. And then that system keeps its notebook pages in a wiki-style format, so a wiki page is made for each batch, and you can see along the bottom the breadcrumb that tells you the location. And variations on this have been installed at a couple other places now. But this was really nice for us because we took an existing system, and then because of the strength of the JChem libraries, we were able to put the two things together with a reasonably small amount of glue in the web application space. Case 3, we work with a company here in town that's a medicinal chemistry CRO. Their labs are in Europe. And so they plan reactions, they synthesize, they get data. Actually, the customers generate the data, and then they plan the next reaction. So it's reasonably typical, except they're working with 5 or 6 different customers simultaneously. And the reagent management is somewhat complex because a lot of times the reagents get shipped to the US and then reshipped to Europe, and the inventory is sort of bicontinental. So they couldn't buy software that did that. We did a reasonable job of looking around for off-the-shelf software to do the trick and couldn't find any. So we wrote them a system in Pipeline Pilot using Pipeline Pilot web forms. And the reason we used Pipeline Pilot is because they already were strong in Pipeline Pilot. They had a reaction planning system up and running in Pipeline Pilot and other things we could leverage. So this is an entire workflow system from searching reagents, ordering reagents, getting them shipped, finding out what happened when they got lost, that sort of thing. In fact, exception handling was probably the biggest component of this when we analyzed how to save their organization time. The regular workflow worked fine. Even if you did it on Post-it notes, it worked fine. But if you had exceptions and you had to tell people that something went wrong, that was where the work went into the system. So we've learned a bunch of things doing this for as long as we've been at it. First and foremost is analyze the science, find the best tool, and then find a way to make it work. If you go in the door saying, we only work with Oracle and we only work with Internet Explorer, you're going to be limited from getting good scientific solutions. Focus on the details. Get the actual science right, numerically, mathematically, everything else. The rest of it doesn't matter if you sort of mess up the science. And these are some of the services we provide. Basically, like I said, information management. Some things I haven't talked about are data analysis of things like qPCR, bioinformatics, other kinds of things. So thank you for your attention, and I hope you enjoy the rest of the UGM.